Good day to all of you. This is the step-by-step procedure on binary, decimal, and octal conversion. Let's start first with binary conversion. From the answer of the polynomial equation, let's convert it to decimal, octal, and hexadecimal. To convert binary to other base forms, specifically to octal and hexadecimal, you must first convert it to decimal. Let us convert 10110 base 2 to decimal number system. Starting from left to right, write down the given binary numbers 1, 0, 1, 1, 0. Then multiply each digit by 2 since the binary number system consists of two numeral combinations. Then use an exponent in multiplying each digit by 2. You should always start from 0 and must be written from the bottom to top. Solve the equation. Then add their product and write down the base number of decimal number system, which is 10. The binary 10110 base 2 is 22 base 10 on decimal form. Now let us try to convert binary number system to octal number system. First, we need to convert the binary to decimal, which will give us the answer 22 base 10. From the converted answer in decimal number system, just like we did earlier, divide it to 8. Get the quotient 2 and the remainder 6. Divide the quotient to the divisor again, and continue doing it until the quotient reaches 0. Get the answer by reading the remainder upwards and write the base of octal number system, which is 8. The binary 10110 base 2 is 26 base 8 in octal form. Let's proceed to binary to hexadecimal. This is how to convert binary number system to hexadecimal number system. Let us first convert 10110 base 2 to decimal. From the converted answer in decimal number system, which is 22 base 10, divide it to number 16. Get the quotient and the remainder, then divide the quotient 1 to the divisor again. Continue until the quotient reaches 0. Get the answer by the remainder upwards and write the base number of octal, which is 16. The binary 10110 base 2 is 16 base 16 in hexadecimal.
Now let us move on to decimal conversion. From the answer of the polynomial above, we will use 1364 base 10 as an example. Decimal to binary. First, divide the given decimal to 2. Get the quotient and the remainder. Divide the quotient 682 to the divisor again and write the remainder. If there is no remainder, write 0. If there is a remainder, no matter what the value of it, write 1. Continue dividing the quotient to the divisor until the quotient reached 0. Get the answer by writing the remainder left to right by reading it upwards and write the base number of binary, which is 2. 1364 base 10 is 10101010100 base 2 on binary number system. Decimal to octal. Just like what we did earlier, we will divide the given decimal number to the base number of the number system that we are going to convert it to. Instead of dividing it to 2, we are going to divide it to 8 because we are going to convert it to octal number system. Get the quotient and the remainder. To get the remainder, we should multiply 8 to the quotient, then subtract 8 to our dividend. In this example, 170 times 8 is 1360. Subtract 1360 to 1364 and we will get the remainder 4. Divide the quotient to the divisor again and continue doing it until the quotient reaches 0. Get the answer by writing the remainder upwards and write the base number of octal, which is 8. 1064 base 10 in decimal is 2524 base 8 on octal. Decimal to hexadecimal. Divide the given decimal number to 16 because we are going to convert it to hexadecimal. Get the quotient and the remainder. To get the remainder, we should multiply 16 to the quotient, then subtract it to our dividend. In this example, 85 multiplied to 16 is 1360. Subtract 1360 to 1364 and we will get the remainder 4. Continue doing it all over again until the quotient reaches 0. Get the answer by reading the remainder upwards and write the base number of hexadecimal, which is 16. 1364 base 10 in decimal is 544 base 16 in hexadecimal.
Let us move on to octal conversion from the answer of the polynomial above. We will use 3052 base 8 as an example. Octal to decimal. We need to convert the octal number system to decimal number system so that we can convert it to octal and hexadecimal later. Write down the given octal numbers starting from left. 3, 0, 5, and 2. Then multiply each digit by 8. Since octal number system consists of 8 numeral combinations, then use an exponent and multiply in each digit by 8. It should always start from 0 and must be written from bottom to top. 0, 1, 2, and 3. Solve the equation, then add their product and write down the base number of the converted number. 3052 base 8 in octal is 1578 base 10.
Octal to binary. We need to convert first the given octal number system to decimal number system so that we can convert it to binary. From the 1578 base 10, divide it to 2 and get the quotient and the remainder. Divide the quotient 789 to the divisor and get the remainder again. Continue until the quotient reaches 0. Get the answer by the remainder upwards and write the base number of binary, which is 2. 3052 base 8 in octal is 110001011010 base 2 in binary.
Octal to hexadecimal. To convert octal number system to hexadecimal number system, we should convert it to decimal first from the converted decimal number. We should divide it to 16 and get the quotient and the remainder. Divide the quotient. Continue until the quotient reaches 0.
Get the answer by the remainder upwards and write the base number of hexadecimal, which is 16. As you notice, there is letter A in the converted hexadecimal number. We need to convert 10 to letter A and 11 to letter B, 12 to letter C, 13 to letter D, 14 to letter E, and lastly, 15 to F. 3052 base 8 in octals is 62A base 16 in hexadecimal. Thank you for listening.